Okay, question 66. Metal sphere R is suspended on an insulating thread. Okay, now I have insulating thread with R ball support. Now another sphere S is brought close to sphere R. Sphere S has a negative charge. Okay, which charge, state, or R counts for the behavior in the diagram. As you see, ball R is attracted to S. We said before, plus with negative, positive, negative, attract. So maybe R is positive. Also we said positive with nothing, no charge, attract. Negative with no charge, attract. So maybe R doesn't have any charge. So the answer is positive or uncharged. Second question. We have two plates, negative and positive. What are the direction of the electrostatic force? And on rod B and on rod Q. As you see, rod B will attracted to rod Q. So this is force on B, down. And Q will be attracted to P. So the force will be up. So electrostatic force on P will be down, and for Q will be upward. Next question. Plastic rod wrapped with a dry woolen cloth. The rod becomes positively charged. It means lost electrons. Which statement is correct? Electrons move from cloth to rod. No, this is wrong, because he said rod becomes positive. It means the rod is lost electrons. Electrons move from rod to cloth. This is correct. And you have to complete proton. Proton, we cannot use proton. Proton is inside nucleus. It cannot be gained or lost. What is the electric field? A region around a wire carrying an electric current. A region in which an electric charge experiences a force. This is the definition of electric field. A student wrap a plastic rod with a cloth. The rod becomes positively charged. So it means lost electrons. Positive means lost electrons. So it has lost electrons. This is what happened. Diagram 1 shows two thin uncharged strips of plastic. And diagram 2 shows the same strip after they have been wrapped with a dry cloth. As you see, we have a repulsion force. What it means? It means the two sides have the same charge, same type of a charge. Which row describes the change? Change on strips. Okay, he said after rubbing, and what's force between the strip. Of course, the force is what? Repulsion force. So I have to cancel this one and this one. So I have to choose. Because they are same charge, they will repel. Same charge will repel. Plastic rod is rubbed with a cloth. The process causes the rod and the cloth to become charged. Charge causes a force between the rod and the cloth. Which row compares the charge on the rod and the cloth and describes the effect of force? Charge on the rod and the cloth, it will be unlike, opposite, because one lose and the other one will gain electrons. So opposite. It will be attraction or repulsion. They will attract. So the answer is A. If we have rod, so, and we have a cloth after rubbing, for example, this will be negative, this will be positive. So the charge will be opposite, and they will have attraction force because they are unlike. Unlike means attraction force. Next, as you see, we have two plates, negative and positive. So the direction between, if we have negative and positive, we said before, what is the direction? It becomes straight lines from negative, from positive to negative. So the answer will be D, from positive to negative. A student holds a rod in his hand. He rubs the rod with a cloth. The rod gains positive charge. It means the rod lost electron. On which material could the rod be made? Of course, the rod must be insulator, because I said before, if the rod is metal, we don't have any charge on the rod, because the charge will flow through the metal to your hand. So we don't have a static charge. So to have a static charge, if this rod is charged, it must be insulators. So I will cancel metal, it must be plastic. And because it lost electron, transfer of a charge, negative charge from rod to cloth, yes, because rod gains positive charge, it means it lost electron. So C is correct. Negative charge from rod to cloth. We don't have any positive charge, can move. A metal conductor is connected to a battery. Which statement describes the current in the metal conductor? Okay, it's a flow of electron from the negative to the positive terminal. Okay, maybe correct. It's a flow of electron from positive to, we said before, if we have a battery, negative terminal, positive terminal, okay, for example. So we said, what is the charge can travel through the wire? It's electron. Electron also repel with negative and attract to positive. So this is the direction of charge of electron from negative to positive. So the answer is A. And of course, you can't choose flow of protons. The diagram shows point X between two charged plates, which diagram shows the electric field. It must be straight line from positive to negative. Easy question. A cell is connected to a lamp as shown. A charge 4. So now what, we have a problem. So what is the given? Charge is Q equal 4 coulomb. Flew through a lamp in 2 seconds. Now we have time T is 2 seconds. What is description? What's direction of the electron flow? Direction, we said before. Direction of electron from negative to positive. And what is the current? The equation, current, if we want to draw the triangle, this is the charge, current multiply time. If we want current, it will be charge over time. 4 over 2 equal to, the unit is amps. So we have current 2, and it is from left to right. Okay, direction of electron flew in the lamp. This is the lamp or bulb. So now we have from left to right. Answer is correct, A. Which quantity is measured in coulomb? We said before, coulomb measure what? The unit of charge. So we will choose charge. The average current during a lightning strike between a cloud and ground is, this is the current because the unit is amps. It released, this is the joule, so this is work or energy. And he gave us time T. What is the average electromotive force? Electromotive force, we have electromotive force equal work done per joule over charge with coulomb, and this is volt. Okay, now if you want electromotive force, you need work done over charge. we have work done or energy. 3 multiply 10 power 8. Okay. Okay. Let me make it bigger. Okay. Now, we have work, but we don't have Q. So you have to find the Q from the equation. I multiply T. I is the current. 1.5 multiply 10 power 4. Multiply time. What is the time? Time is 2 multiply 10 power negative 4. Now what is the answer? It will be 3 column. So I have to put here 3. Now what is the answer? It will be 1 multiply 10 power 8 volt. So the answer is C. Which circuit shows the direction of a conventional current? We said conventional current from positive to negative. From positive, the long line, to negative, the short line. So this is the current direction, and the electron direction will be the opposite. So B is correct. B is correct. The diagram shows the circuit. The reading on ammeter is 12. So ammeter read current. I, current equal 12 amps. How much charge passed? So he asked about charge in column and gave you the time is 2, but be careful, this is 2 minutes. You have to convert 2 multiply 10, no, 2 multiply 60. It will become 120 seconds. Now, what is the triangle? Q, I, T. So we want to charge Q. It will be I multiply T. I is 12. T, 120. So it will be D, 1440. The unit is coulomb. And you have to be sure all with the same unit, because sometimes he will tell you 1440 coulomb, 1440 amps, for example. So you have to be sure your answer in coulomb. In the circuit shows the voltmeter. We have a voltmeter, so this is voltage, 2 volt, and the charge Q equal 5 coulomb. Okay, now how much energy? He asked to find work or energy. The equation, again, work, voltage, charge. If we want work, work equal V multiply Q. 2 multiply 5 equal 10 joule. So the answer is 10 joule. What is the unit of a charge? Coulomb. Which quantity is equivalent to 1 volt? We have to use the triangle. Volt for V, volt. Work, joule. Charge, coulomb. So, as I said in the class, volt equals joule per coulomb. So, 1 volt equals joule over coulomb. This is the correct answer. A battery is connected to a circuit. It's switched for 1 minute. So time equal 1 minute multiply 60 equals 60 seconds. During that time, there is a current. He gave you the current 0.4 amps. And we have energy. So work or energy equal 48 joule. He asked to find the charge and EMF, because we have this triangle. Now we have 2 triangles, charge, current, time, and the other one is work, electromotive force, voltage, and charge. So first we have to find the charge. Charge equal I multiply time. I multiply time, means 0.4 multiply 60 equal 24. So the answer is 24 for charge. We have 224, so we have to find EMF. What is EMF? W over Q, work over electron over charge. So now we must find electromotive force V. V equal W over Q, okay, equal W is 48 over 24 equal to, so the correct answer is C. In an electric circuit 40 coulomb, we have a charge equal 40 coulomb. Pass point, this is the time, 5 seconds. Repeat after me. Current. Current equal Q over T. So this is 40 over 5 equal 8 amps. So the answer is 8. An electric meter record. Be careful here. Pay attention. 200 megajoule. Now we have work or energy 200 megajoule. To convert it to joule, so 200 must multiply in 10 power 6 because mega is a million. Million is 10 power 6. Now we have energy equal 2. By using your calculator, it will give you 2 multiply 10 power 8. We have 2 and 8 zeros. Joule. Okay, now the next. This is a hard question. The only hard question in this homework. And he gives you 240 volts, so this is the EMF or V equal 240 volts. Now he said, what is the average rate of electric charge passing through the meter? And be careful because the unit is C over H or Kc over H. What it means, we want to find the charge first. You have to find the charge from the triangle. Again, the triangle is what? Work, charge, volt. So the charge will be W over V. So now W2 multiply 10 power 8 over V 240. Now I will count. I will use my calculator. 2 multiply 10 power 8 divided by 240 equal, it will be 8.3. So now Q is 8.3 multiply 10 power 5. Now this is the charge in coulomb. He asked to find charge, okay, but divided by hour. You have, because he wants the rate, the average rate, so you have to divide by 60 because this is coulomb, and he wanted each hour. Each hour you must find what? You must find divided by 60 divided by, because this is the charge, okay, and he said 24 hours, so you have to divide by 24. You have to divide by 24. So I will divide it by 24 equal 34.72 34. So now I will divide. Q equal 34.7 multiply 10 power 4. 34 power 3 using your calculator. Now the only number so close from 34 is 35, and this 10 power 3 is kilo, so the answer is 35 kilo coulomb per hour. This is the answer. A student investigates the resistance of a lamp which rotate a meter the reading. How the meter must be connected. Of course, as you know, a meter is connected in series, but voltmeter is connected in parallel. So I will choose series and parallel, so it will be C. State what's meant by direction of electric field. Okay, this is a definition, and I said this is the direction of force, okay, affect the charge placed in electric field at this point. Okay, now we have 3 marks here. Okay, he said draw a line on figure 9.1 to represent the uniform field. Uniform field, straight lines, and direction from positive to negative. From positive to negative. Okay, and keep equal distance. Next. Now we have this question. When you read this question, you will find what? He gave you charge and time and ask you to find the average current. Again, you have to write the equation first. Current, and you don't have any converting, so current equally charge over time. Charge is 0.84 over time, 3.5 multiplied 10 power negative 5. What's the answer? I will use my calculator. 0.84 divided by 3.5 multiplied 10 power negative 5. So the answer is 24,000. 24,000. What is the unit? Amps. Don't forget unit. 24123 amps. Next. Describe in terms of particles and the terminals of the battery the movement of a charge in an electric circuit. Okay, now what's the particle move? Electrons move from negative terminal to positive terminal. Okay, the potential difference PD, he gave you this voltage potential difference. Okay, and in the same question he asked you to find what? Calculate the energy transferred during the lightning flash. Okay, now we have the charge is 0.84. 0.84. Okay, so if we want to find energy or work, it will equal Q multiply V. So you will gain 1 mark for the equation as I said before. Q is 0.84 0.84 0.84 multiply V is 2.5 multiply 10 power 8. Now what is the answer? 0.84 multiply 2.5 10 power 8 equal 21 multiply 10 power, how many zeros? 1 2 3 4 5 6 7 zeros, and the unit is what? Joule. So this is a big mistake from me, so I will forgive you if you make it wrong, because this is B, we have B I and B I and A come in the another part, so this is my mistake. Okay, so no problem. If you solve it by mistake, I will correct it to you. A charge of, he gave you the charge and the time, but be careful, time is 5 minutes, 5 multiplied 60 equal 300 seconds. Calculate the current. What is the equation? Current equal charge over time. Charge, or every time you have to write the equation to memorize it in the test. Charge is 7 over time is 300. Now what is the answer? I will divide 7 over 300 equal 0.02 amps. After rounding, use one significant figure. Now, show two uncharged conducting spheres suspended on insulating thread. The spheres are now both given positive charge. Now we have positive here and positive here. Okay? Draw a possible position of each sphere and thread. Now we have to draw a possible position, of course, because they have like a charge or same charge, they will repel. So this one will repel, this one will repel, both will repel, so they will be like this. Repel, positive, repel with positive. So this is the new position. Explain the position you have drawn. I will write what? Like, charge, repel. So both have same charge, they repel. We have a negative charged rod and a positive charged cube. State and explain any movement of the piece of wood. Where is the piece of wood? This is the piece of wood. Where positive charged cube, negatively charged rod, piece of wood. Now the piece of wood will move toward the rod because positive and negative will attract. So I will write the rod, the wood, the piece of wood, move to left because, let me make it clear, because the cube will attract to the rod. Okay. In terms of a simple electron model, describe the difference between conductors and insulators. So I will write conductors have free moving electrons or free electrons to make it easier to read. Alright, moving have free electrons, and insulators doesn't or don't have free electrons. So he said in terms of simple electron model, describe the difference between conductors and insulators. How conductors have free electrons but insulators doesn't have free electrons. On figure 8.3, draw an electric field pattern around a single positive. So it will be as we take it before, right, left. You can draw at least 4 lines. Don't forget the direction or you will lose 1 mark. This is the direction. Away from positive. Okay, now last question. When you read this question, state how the structure of an electrical insulator differs from a structure of conductors. Conductors have free electrons, but insulators don't have free electrons. Okay, now suggest why the handle are made from electrical insulator. Of course, the handle for the doctor must be insulators to prevent any electrical shock to the doctor. To prevent any charge to reach doctor. Okay, so it will keep him in safe from electrical shock. In terms of particles involved, how one contact become positive negative and the other one become positive, because one contact connected to positive terminal and the other one connected to negative terminal. Okay, terminal means like a battery, for example. So because one contact connected to positive and positive pole, and the other one connected to negative. Now the last question, he gave us number with C, so this is Q, 9.1 multiply 10 power negative 3, and we have time T equal 6.5 multiply 10 power negative 4, and they asked to find the current. Current equal, again have to repeat, Q over T, 9.1 multiply 10 power negative 3 over 6.5 multiply 10 power negative 4. So now what is the answer? I will use my calculator. 9.1 multiply 10 power negative 3 divided by 6.5 10 power negative 4 equal 14. So the answer is 14 amps. This is the answer of homework. Okay, you can watch this video and correct your mistake, and see you soon. Thank you. Bye bye.